Thank you everyone. Today I discuss about the practical application of echo. First of all, echo. Echo is the repetition of sound due to the reflection of it from a distant object. By using echo, we can find the depth of the water body. Water body means it may be ocean, sea, lake, etc. To find the depth of the sea or ocean or any water bodies, we use a device sonar. Sonar, when you write down in spelling, then must be write in capital letters. Here, sonar, S-O, it stands for sound. NA, it stands for navigation, and R stands for ranging. This sonar have two parts. One is the sending part and another is the receiving part. And with these two, there is a automatic stopwatch to count the time for time interval for any program. In sonar, we use the ultrasonic sound or ultrasonic wave. Why? Because of ultrasonic wave have higher frequency and have greater energy, so it can travel a longer distance. Now, this ultrasonic wave is sent from the sonar towards seabed, and the reflected wave from seabed is received by the sonar. The time taken by this ultrasonic wave traveling from sonar to the seabed and coming back is noted by the stopwatch attached to it. So by using the recorded time and the velocity of sound in water, we can find out the depth of the sea by using the formula velocity of the sound in water into time divided by 2. This is the procedure how we find out the depth of the water bodies. Now, the second use, height of an aeroplane. Here we also use a sonar. An ultrasonic sound from sonar in the aeroplane is sent, and the reflected wave from the ground is received by that sonar. The time taken by ultra wave traveling from sonar to ground and coming back is noted. Here, the velocity of the aeroplane has to be considered, because the aeroplane does not remain stationary at a place. If we know the velocity of the sound in air, velocity of aeroplane and recorded time, then you can find out the height of the aeroplane from the ground is given by h is equal to recorded time divided by 2 into whole square root of velocity of sound square minus velocity of aeroplane whole square. This is the way how we find out the velocity of aeroplane. Now the third use is the determination of velocity of sound in air. Here we choose a wide open space where a high wall stands. a person stands at a certain distance from the wall, but this certain distance must be suitable for hearing echo from the wall. Now this person fires a gun or pistol and simultaneously starts a stopwatch. The sound of pistol reflects from the wall and that person hears an echo after a certain time. On hearing the echo, the person stops the stopwatch immediately. So, the time recorded by stopwatch gives the time of traveling of sound from the person to wall and come back to that person. So, if you know the time recorded time and the distance of wall from that person, then you can find the speed of the sound is equal to 2 into distance divided by time. Also, by this formula, by using this formula, you can find out the distance of the distant reflector if you know the speed of the sound in air and recorded time. Also, for the depth of the sea, first application here, we can also find the velocity of sound in water. How? By using the recorded time and if you know the depth of the sea or depth of the water bodies. By using this depth of the sea and recorded time, you can find out the velocity of sound in water. Now take some numericals. An ultrasonic wave is sent from a ship towards the bottom of the sea. It is found that the time travel between sending and receiving of the wave is 1.6 seconds. What is the depth of the sea? Take the wave of the sound in seawater is 1400 meter per second. Here the speed of the sound is in water, it is given 1400 meter per second and time is given 1.6 second. By using the formula, depth of the sea is equal to velocity of sound in water into time by divided by 2. Velocity of sound, it is 1400. Time recorded by the sonar is 1.6. It is 1.6 time. By cancellation, it will be 700 into 1.6 and it will be, if we multiply, then you get, it will be 1120 meter. So, depth of the sea is 1120 meter. Now the another sum. An echo is heard from an distance cliff after an interval of 0.8 second. If the speed of the sound in air is taken 340 meter per second, how far away the cliff from the listener? What are given? Given is the speed of sound in air, and it is 340 meter per second, and the time taken is 0.8 second. We know that the velocity of sound in air, the formula is 2 into distance divided by time. So by side change we can get distance is equal to velocity into time divided by 2. Velocity into time divided by 2. Velocity is given 340, time is given 0.8. By cancellation it will be 170 into 8, 0.8, then it gets 136 meter. So the distance of the cliff from the person is 136 meter. Now an homework you can try to do yourself. From a ship, an ultrasound signal is sent to the seabed and its echo is received after 4 seconds. If the depth of the sea is given, it is 2800 meter. Find the speed of the sound in water. Try to yourself. Thank you.